Hi, it's me, Dr. Prasad Puthiyillam, with my classes on organic chemistry, class number 2. I'm explaining the inductive effect, resonance as well as mesomeric effect in this particular video. So, electronic effect, first one inductive effect. Say if I take the example of a carbon with tetravalency and one of the valency is connected to a nitrogen or to sulfur or to oxygen or to halogen or to phenyl or any such type of atom or group of atom with a difference in electronegativity or difference in charge separation or difference in electron density, then such type of effects we have to discuss. That means movement of electrons, electron movement or electron displacement effects. Some of them are inductive effect, I effect, resonance R effect, mesomeric effect, that is M effect, then hypoconjugation as well as electromeric effect. This particular class covering the inductive effect, resonance as well as mesomeric effect. Inductive effect, it is a permanent effect. It transmits along the sigma bonds and it is distant dependent effect. Say example, if I take a chain of carbon, three carbon I took, satisfied the valency by bond, some hydrogen or alkyl groups are there. It is connected to an atom or group of atoms, say X. X can be treated as halogen also, which is more electronegative atom. Then the electrons present in that CX bond, the electron density or the shared electrons, it will be shifted towards the more electronegative atom and creating a partial negative charge on the X or a more electronegative atom and partial positive charge on the carbon atom which is connected to that. This effect will continue. The partial positive charge on carbon to satisfy, because it become a electron density difference happened. Therefore, the next group bond, carbon carbon bond, the electron density will shift to the carbon, and it gets a partial positive charge, and it continues to up to a third carbon atom, which will get a partial positive charge, and it is distance dependent effect. It cannot go above a carbon 3 or above a chain of 3 and above with a sigma bond. Atoms or group of atoms with withdrawing electron density, which are capable to withdraw the electron density, are called a minus R effect. Say example, Nr3 with N with a positive charge. Anyhow, it is having positive charge, therefore it is highly electron withdrawing group. The next molecule, the power, if I discuss, the negative group, the decreasing order of atom or group of atoms. The next one, that is Sr2 plus, then NH3 plus, NO2, SO3H, cyanide, aldehyde, ketone, acid, halogens, OR, OH, terminal alkynes, NH2, and phenyl, then terminal alkenes. Okay, so terminal alkynes and terminal alkenes in between, there is NH2 and phenyl group in between. If an atom or group of atom which is having the capacity to donate electron through a covalent bond, we call them as a plus I group. Say example, O minus, COO minus carboxylate ion, tertiary butyl group, isopropyl group, ethyl group, methyl group, deuterium. Then comes a hydrogen. So hydrogen is in between that of a plus I effect and minus I affecting groups. The next one, that is resonance effect. Resonance effect and mesomeric effect. The difference is that resonance effect is bidirectional effect, as well as mesomeric effect is unidirectional effect. So the conditions required for the electron movement, which we call as the resonance effect, which was invented, or the name was given by Heisenberg. Molecules must be planar and should have conjugation. Conjugation means it should have alternate single and double bonds like this. So this is an example of a benzene. So here benzene, we can write either structure 1 or structure 2. Both structure we can use while writing a chemical reaction with benzene. But actually these bonds are not as such present as is indicated here. It shows a partial, yes, a single bond, a double bond, a single bond, double bond. Whereas here all the carbon carbon bonds are equal in distance, that is 139 picometer, which is in between that of carbon carbon single bond and carbon carbon double bond. Therefore it is better to represent the benzene like this, with a circle inside this hexagon. This is known as a resonance effect. So here, because these two structures contribute towards the real structure of benzene. The first two structure we call it as hypothetical structure or resonating structure or canonical structure, and the real structure or resonance hybrid, which is the lowest energy resonance structure. The molecules which exhibiting resonance effects are M, atom M connected to atom N through a bond, and the atom M is having either lone pair of electron or negative charge, and atom N is having positive charge. So here resonance structure is possible. This electron density or negative charge, it can form a double bond here. Therefore, this positive charge will be neutralized, or possible with two atoms doubly bonded M double bond N and connected to another atom which is in conjugation. So it is conjugation is compulsory. The electron that means alternate single and double bond, or alternate lone pair of electron, alternate charge separation. If it is there, this is possible. Therefore, if Y is having a positive charge or Y is having negative charge, or lone pair of electron, or free radical, or even if Y is connected doubly bonded to another atom or group of atom, or if it is triply bonded. So all these cases the molecule can exhibit a resonance. Other molecules which you can represent having triply bond, say M triple bond N, and connected to a conjugate atom, that is where we expect the conjugation for the resonance. It is having either positive charge, negative charge, or lone pair of electrons, or free radical, or double bond. Even triple bond also will represent that. Or if M connected to N through a double bond, which is connected to the conjugate atom Y, which is having positive charge, negative charge, lone pair of electrons, or free radical, but Y is connected to another atom Z with a multiple bond, a double bond or triple bond. Then the electron movement will takes place only with the double bonded, that pi conjugation only the electron movement takes place. The positive or negative charge will remain as such in the resonating structures. Therefore here I can represent the electron movement. It can be like this, and the positive charge, negative, lone pair of free radicals are not participating in this resonating structure. Say example, if I take to explain the resonance stabilization or resonance effect, I took phenol. Phenol oxygen is having a lone pair of electron, and benzene molecule is already in conjugation. They are planar structure. Therefore, a movement of electron like oxygen lone pair of electron will try to form double bond with the carbon connected carbon of the benzene ring. Then the next double bond it will shift, and a double bond is formed between oxygen and carbon having positive charge on oxygen and a negative charge to the so-called ortho position. So that is we call as the ortho position with respect to OH. Then that electron density will shift, and another negative charge, a double bond shift, and a negative charge at para position, which again shift. The electron shift movement is represented here, and we'll be getting a double bond in that position and a negative charge on another ortho position, which again shift back, and we'll be getting the other structure of phenol. Therefore, phenol, it is showing the resonance effect, and that free lone pair of electron it got back. And we know that this in this case the electron movement is away from the OH group. Another example aniline is given there, in which the electron movement, the lone pair of electron, the electron movement is toward inside the benzene ring, or it is away from that. That means the transfer of electron is away from an atom or substituent group attached to the conjugated system. Then this electron displacement affect a certain position molecule having high electron density. So some of the points they are having high electron density, they are the ortho and para positions. This type of group we call it as a plus R affecting group. Say example, halogen, OHOR, OCOR, NH2, NHR, NR2, and NHCOR are example for group which gives a plus R effect. Minus R effect, if you take example, benzaldehyde and nitrobenzene, here the movement of electron is away from the benzene ring, or it is towards the group atom or group of atom. So this effect we call it as minus R effect. The last topic, that is mesomeric effect, which is unidirectional. Mesomeric effect, to explain that, I take this example: a carbon double bond carbon with connected to an aldehyde, a terminal aldehyde group. So here, due to the presence of C double bond, the electron movement will be towards oxygen. Then this double bond will break to CHC. So here I can say that the electron movement is towards the aldehyde group. So aldehyde group, it can be treated as a minus M effect. So here it is unidirectional. Only the electron movement takes towards this aldehyde group. Then as such, the movement to back, it is not as such possible. Therefore, we call it as mesomeric effect. So the group or group of atom having multiple bond or more electronegative or without a lone pair of electron will give the minus M effect. Say example, the power is represented here: NO2, SO3H, cyanide, aldehyde, ketone, acid, and mild, CONH2. So this is the order of decreasing order of minus M effect group. If the OH group is connected there to that one, then in this case, so it's a double bond conjugate uh, position, that is oxygen, having lone pair of electron. Therefore, resonance is possible. Here, the electron movement will be away. So this lone pair of electron will try to form a double bond here. This double bond will shift here, and carbon will get a negative charge. Therefore, here you can say that it is plus M effect. That is, the atom or group of atom, whether it is connected to a multiple bond or having negative charge with lone pair of electrons, they shows plus mesomeric effect. Say plus mesomeric effects are given by O minus, NH2, NHR, NR2, OHOR, NHCOR, OCOR, fluorine, chlorine, bromine, and iodine. They are either having negative charge or having a lone pair of electrons. Hope you understood these basic concepts of organic chemistry. Thank you very much for watching. Those who are not subscribe my YouTube channel, please do subscribe my YouTube channel and support me. Have a nice day.